Okay, so let's look at just one example where we're showing how to generalize these definitions of linear approximations, differentiability, and differentials to functions of more than two variables. Okay, right, so three or more variables. So linear approximation, here we go. You'll still have your value at the point plus those partials times the difference in x, y, and z variables. So this right-hand side here is called the linearization of f at the point a comma b comma c. Okay. The linear approximation is this entire approximation here, right? If this is valid, then we say f is differentiable. And again, we have a definition with the different epsilon 1, epsilon 2, epsilon 3 going to 0. But we won't really worry about the formal definition of a function being of three or more variables being differentiable. Let's look at the increment. The increment is going to be very similar to the increment in other situations. So let's look in one dimension. So for one dimension, what do we have? We had delta y was equal to f of x plus delta x minus f of x. In two dimensions, we had delta z is equal to f of x plus delta x, comma, y plus delta y, minus f of x, comma, y. So now in three dimensions, if you have delta w equals, and we have this right here, what we have right here, right? So it's x plus delta x, comma, y plus delta y, comma, z plus delta z, minus f of x, comma, y, comma, z. Okay? And then for the differentials, you just take that partial. This, remember, is going to be independent variable. So this is going to be an input. Your dy is going to be an input. And your dz is going to be an input. Okay? And you just take partials with respect to x, y, and z. Let's look at this example. And this will be our last example for this section. So the dimensions of a rectangular box are measured to be 75 centimeters, 60 centimeters, and 40 centimeters. And each measurement is correct to, within 0.2 centimeters. So, let's see here. Use differentials to estimate the largest possible error when the volume of the box is calculated from these measurements. Okay, so we know if we have a box, the volume of the box is going to be length times width times height. Okay. So if we're using differentials, then we would say dv is going to be the partial with respect to length of v at length times width times height times the differential in length plus the partial with respect to width times the differential in the width plus the partial with respect to height, length, width, height, times the differential with respect to height. Okay, so that's our dv. Now, we are told, so since v is equal to L times W times 8, that means that the partial with respect to L is going to be WH, the partial with respect to W is going to be LH, and the partial with respect to H is going to be LW. So we should get WH times DL plus LH times DW plus WL DH. Okay? And now we were told, so we can figure out 75, 60, 40. Okay, so we'll just make that to be equal to our L, that to be equal to our W, and our height to be equal to 40. So 75 is L, HW is going to be 60. H is going to be 40. And DL is because each of the increments are going to be, sorry, each of the differentials is going to be 0.2. So let's do 0.2. And then, so H, we said that's going to be 40, and that's 0.2. And then W is going to be 60. L is 75, and that is 0.2. So altogether, we should get, let's see here, so 60 times 40, 75 times 40, 60 times 75, and then all of that times 0.2, 1980. Now, what are the, I think perhaps I forgot to do this on the last problem. What are the units? Units. So here's the deal. The units for W are going to be centimeters. The units for H are going to be centimeters. And the units for that differential, centimeters. So each of these units is centimeters. So this should be centimeters cubed. Okay. So this is our differential. And now we might be thinking, whoa, that's a big differential. But now what is the volume? If we just use the formula for volume, we would get that the volume is 75 times 60 times 40. What is that? 75 times 60 times 40. 180,000. So 180,000 plus or minus 1,980 centimeters cubed. Okay. All right. And that's it.